All right, here we go. It is Monday, January the 18th. We're going to start out today putting some notes in our composition books. So if you would go ahead and open to your first clean page. Jackie, do you still have your composition book? Jasmine, you still have your composition book? Okay. Okay. January 18th. So just a quick review. What we have been talking about up to now is integers. Who can tell me what were the four things that define integers? Please close your Chromebooks. Everybody, close them up. What are the four things that describe integers? Henry? Yeah, positive numbers. Write this down. Negative. What else?
They're whole numbers.
Whole numbers. And zero. Absolutely right. Today we're going to talk about something called rational numbers. And I'm going to describe rational numbers for you. So I'm going to start that list. And I want you to tell me what you notice when you finally notice it. What do you notice, Izzy?
That they're all the same integers.
It's exactly all of the integers plus this. We're going to add fractions and decimals. So if you look at the number lines on your table, okay? That was weird. I know, we don't want everybody at home to know that Madison just fell out of her chair onto the floor. Oh, I'm sorry. Was I talking while the video was going? It was Madison Carpenter. Okay, so basically this. Integers, we already know about integers. Rational numbers are going to include all the integers plus positive and negative fractions and positive and negative decimals. So that's the new part today. There are certain fractions that are the most commonly used fractions that you should memorize. So I'm going to give you a short list and then we're going to talk about how to remember them. All right, so watch this. One of the most common fractions we will use is 1/4. Write it down. Also 2/4, which happens to be the same as 1/2. Go ahead. 3/4 and 4/4. So those are really common fractions. Look what happens when I tell you what are the decimal equivalents that go with them. What do you notice? Henry?
It's like a time up at 25 cents. It's like a dollar bill.
It's like counting by quarters, right? 1/4 can also be called 1/4, 25 cents. 2/4, which is really half of a dollar, 50 cents. 3/4, 75 cents. 4/4, $1. So if you can remember how to count by quarters, you can remember all those fraction and decimal equivalents. That's just a really easy way to remember them. Another set of fractions that you see a lot is 1/5. And there'll be a pattern here too. Remember we talked about fractions are division problems. You got to write this down, Henry. Fractions are division problems. So this is actually 1 divided by 5. So if you were to take out a calculator, which I don't want you to have to do, and you go 1 divided by 5, this is what you get. 2 divided by 5 And that's what you get. See the pattern already? So for fifths, if you can remember the first one, then you know how to use the pattern to find all the rest of the fifths. So if you can remember quarters, you got this taken care of. You can remember 1/5 equals 0.2, you got this one taken care of. And then this is the next easiest, or this is the next like most common one. Go all the way down the page. Guess what the decimal is for 1/10?
10.
Nope, but that's a good guess. Isaiah, it is 0.1. So guess what 2/10 is going to be? You are guessing it. Go ahead and fill that in. That pattern's super easy, right? That pattern's super easy. And then I'm going to show you two more fractions. They're very common and they're very crazy. And I'll show you what I mean. 1/3, super common fraction, right? So watch what happens. Fractions are division problems, so this is actually 1 divided by 3. Look what happens. That never stops. It goes on into infinity. So you really can't write the actual decimal for 1/3, right? Because I could write 0.3 for the rest of my life until I die and I still wouldn't be done because it does never end. So you obviously can't use that decimal in its full form because you just can't manage it. So here's how you write that fraction or decimal. 0.3, and there's a line over the 3, and that line means repeating. So this is 0.3 repeating, which means that never stops. That is an estimated decimal. Because it goes to infinity and never ends, it's not an exact number. Whereas 1/3 is an exact fraction. That's an estimated decimal. And 1/6
Same thing.
well, look carefully. You only put the line over the part that repeats. 0.16 repeating. If it was 1616161616, you'd put the line over both numbers. Okay? So there are some fractions like that. So I'm telling you this because we've talked about it before. Sometimes when you're doing a math problem, it's easier to use a fraction, and sometimes it's easier to use a decimal. And you can pick either one because they are exactly the same value, except for these two. And in these cases, you always want to use the fraction because that's an exact amount, that's an estimated amount. Now you can close your composition books and we're done with that. We're going to talk about lesson 6. And lesson 6 is all about rational numbers. So remember, the only thing we're really adding to this is now we're going to start putting fractions and decimals on a number line. And that's sort of the goal of today's lesson. How do you figure out how to make fractions and decimals go on a number line? Okay, so let's start here. This is a quick review. What is the opposite of positive 1/2? Madison? The opposite of positive 1/2. Exactly right. See, that's not hard. The opposite of 4/5. Cooper. Negative 4/5. The opposite of 6 and 7/10.
Negative 6 and 7/10.
Yep. Now, you know what I just realized? I made a mistake. What did I do wrong? I did not read the directions. Write the decimal for each fraction. So see what happens when you skip directions? Which I did. So we have to write a decimal for 1/2. We just did that in our books. Who remembers? What is 1/2? Madison? What is the decimal for 4/5? Henry?
180.
Now this one's a little bit different because it has a whole number and a fraction. So I have to write 6, and that's where the decimal reads. When you read a decimal point, you say and. 7/10 as a decimal. 6 and 7/10. So let's go back and talk a little bit about 5th grade. 3rd grade, 4th grade, 5th grade actually. When you learned place value, you first learned ones, tens, hundreds, thousands, right? Then in 5th grade, you added the decimal parts. The first place value after the decimal is called what? Tenths. Exactly right, Cooper. Good job. What's after tenths, Cooper? Yep. And last but not least, Cooper? Thousandths. So keep that in mind. We're going to take this and we're going to change it into a fraction. So let me read this and you tell me what you think it would be as a fraction. That is 42. Say the number first, and then say the place value name. So there's 2 numbers after the decimal, so the name is going to be what? 42 what? Hundredths. Watch this. 42 hundredths. I'm going to change this. Now I've got a whole number. 3 and then I say the number 75. It's got 2 places after the decimal. What's the name, Henry? 75 hundredths. Let's look at the last one. 36 and what fraction do I put? Henry? 90 hundredths. Does anybody come up with a different answer for that one? I thought of 2 answers actually. Watch this. Remember when we did this? So it's also 36 and 9/10. See how the 9 is in the tenths place? So we don't even have to deal with the 0. So that's an idea for you guys to think about. Let's go on to the next point. So far. Now at the top of here with example 1, they give us all this writing stuff. Let me summarize for you basically the gist of what they're talking about. Rather than try and ask you to read through that, interpret it, write it down. You know this. You write a fraction, a over b, as long as b, what? Does not equal 0. So you know that, right? Okay, now we're going to talk about a unit fraction. So you're going to highlight unit fraction. And a unit fraction is when you count by some fraction, and the b is the unknown number. So whatever b is the equal number of parts. And I'll tell you what I mean by that. So just write that down to start with. So we're going to use this as our first example. B is the denominator, right? So what's my denominator this time? 10. I need to make sure that between 0 and 1, there are 10 equal parts. So how many tick marks do I need between 0 and 1? Not 10, because this counts for one of them. 9, it's always one less. So put your 9 tick marks in. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now each unit is supposed to be equal distances, right? So each of these times I move over, it's 1. And then how many equal parts are there altogether? So the unit fraction is 1/10 on this number line. Now let's do the same thing on the other side. 9 tick marks. So every time I move on this number line, I am moving by 1/10. So the main thing is you figure out how many equal parts do I need? 10, and the top number tells me how far to count over. So start at 0 and count over how many times? 3. 1, 2, 3. This right here is 3/10. So the bottom number is how many equal parts, and the top number is how many to count over. Now, what's going to be the opposite of 3/10? Izzy? Negative 3/10. So any number and its opposite, we know they're on opposite sides of 0, and they're the same distance away. So now I'm going to count this way how many times? 1, 2, 3, and this would be negative 3/10. So that's the first one of those that we've done. Here's the second one. Let's try it again. I'm looking at this fraction. The bottom number tells me how many equal parts I need, and the top number tells me how far to count over. What do you notice about this number line right off the bat? First thing you notice about it, Madison? There's no numbers. And what number do I have to get to start with?
0.
So we got to go put 0 in. Remember how you do it? I've already counted. There's 17 tick marks. So 17, we're going to take 1 away to use for 0, which leaves me with 16 left. How many on each side?
8.
Watch this. 1, 2, 3, 4, 5, 6, 7, 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I know I've got 0 now. Now you look at the fraction, you look at the denominator. How many equal parts do I need? Henry?
7.
No, denominator.
Oh, 4.
Divided into fourths. So watch how I do that. You guys ready? 1, 2, 3, 4. 1, 2, 3, 4. Those are my whole numbers. There are fourths in between. Now I need to do the same thing, go in the other direction, exactly the same time. 1, 2, 3, 4. And 1, 2, 3, 4. So that's how you use the fraction. You use the denominator to say how many equal parts between the whole numbers. The top number is how far over I go. I'm going to go over -7 spaces. So if I start at 0, do I go to the right or to the left? Kylie. And how many times do I go over to the left? How many times do I move to the left? 7. Ready? 1, 2, 3, 4, 5, 6, 7. And to find the opposite, I go back to 0, go the other direction, the same exact number of spaces, right? 1, 2, 3, 4, 5, 6, 7. On the number line, each segment will have an equal length of, what did we say each of these spaces equals to? Not 4. It's less than 1, isn't it? From here to here is less than 1. 1, 2, 3, 4. We divided it into 1/4. Remember, the 4, the denominator is always how many equal spaces there are. Okay, so this number right here is between what two integers? Oh, now we're back to integers, so we're back to whole numbers again. That is located between what two integers? Olivia, positive or negative?
Positive and negative.
Nope, this number right here.
Negative.
Between -1 and -2. Very good. Between -1 and -2. Okay, one more page here. Now I've got, what kind of number line is this one? Horizontal or vertical? Vertical. This is actually a rain gauge. So what a rain gauge is it's a container that has measurements on the side, and when it rains, it fills up, and that's how they count how many inches of rain you get. All right, so check this out. The water level of a lake rose 1.25 feet after it rained. So here's before rain. Then there's a whole bunch of rain. Does the water level go up or does it go down? Ben?
Up.
It's going to go up. So is that a positive number or a negative? So it's going to be a positive 1.25 feet. It's going to go up that much from 0. Now it says what two integers will that be between on the number line? So here it's a positive number, so it's going to be this way somewhere between 0 or 1 or 2. If it's 1.25, so here's 1. Is it going to be more or less than 1? More. So it's going to be in between 1 and 2, somewhere in here. Now let's look at between 0 and 1. How many equal moves are there? Watch this. 1, 2, 3, 4. One-fourth. And what decimal is equal to 1/4? Henry?
1.5.
Yep. We have to mark our rain gauge. Write the length of each segment on the number line as a decimal and a fraction. So this is going to be, right here is going to be 1/4, 1 and 1/4. And it's also 1.25 because 1 is right there. 0, 1, and 2. So the level of water after it rained is going to be all the way up here. One more question on this side. After 2 weeks have passed, the water level of the lake is now the opposite of the water level when it rained. What's the opposite of this?
Negative 1.25.
And where is that on the rain gauge? Well, if positive 125 is above 0, negative is going to be below 0. And remember, it's the same distance away from 0. So we went all the way to 1 and then picked the very next target after 1. So watch this. Go all the way to 1, Pick the very next tick mark after 1. And now the water level's all the way down here. Okay? So please take a look at your problem set. On the problem set, I want you to circle number 1 and number 4. And those will be your assignment for this lesson. Okay? So you can go ahead and work on that. Sure, you can do that. Okay, questions 1 and 4 only today for homework. If you're doing this from home, if you're homesick or CE students, please turn this in on Cami.